Good afternoon, everybody, and welcome to this second session in this track on Friday, the last day of the career week. My name is Henry Bain, and it is my pleasure to talk to you this afternoon about modern system-to-system authentication using Azure. In case you're wondering who I am, my name is Henry. I'm a developer and architect from the Netherlands, and I've been working with Microsoft Azure for about 10 years. I work as a consultant and architect for different countries in the Netherlands. And besides my job, I try to do presentations like this. I've written books and I create courses for Pluralsight and a Cloud Guru. And especially for this talk, I went to Manning, which is the publisher of my last book. And just as at any proper conference, I have something to give away for you. You can get a 35% discount on this book using the code you see at the bottom right of the screen. And the talk is recorded and this code will continue working for a while. I also have 2 Pluralsight trial codes to give away. So if you're interested in those, just reach out to me on Twitter and I'll see if I can get those to you as well. But you're not here for that. So let's talk about something else, and that is system-to-system authentication. I've been thinking about system-to-system authentication for a while now. There are a number of problems that I've encountered in my career that were a pain in the butt and that at some point we managed to solve. For example, provisioning using infrastructure as code or deployments using pipelines. But system-to-system authentication is a problem that I've been facing for quite a while in my career, and only I think like 2 years ago I really started to overcome using the increasing support for managed identities in Azure. And in this talk I want to share with you the problems that I've encountered in different companies using system identities and working with them, and then how we can take a completely different approach using managed identity in Azure. Now, if there are any questions, feel free to reach out to me using the questions option. I should be able to see them come in, and I will try to answer them as I go along. Or if we have time left at the end, I will answer questions at the end as well. But feel free to ask us. The more we can make this like I'm talking to somebody instead of just talking to a camera, that will be awesome. So if I talk about system-to-system authentication, I'm talking about things like this. Shared keys, symmetric keys, for example, an API key that I need to use for calling another system. And of course, the problem with that key is, how do I store it securely in a way that still the application that needs it can get it, developers that need it can get it, but no one else can get it. The same goes when I have to use a username and password for accessing a system, or when I have to use a client ID and a client secret for accessing a system. Basically, all 3 options are just, a password or a username and a password. We could also be using certificates, or maybe a client ID and a client certificate. But in all situations, we are talking about a problem where a system should be able to prove its identity to an authority and get a token or something, some proof in return, and go to another system, which is called the resource, to do things, or go directly to the resource using the username and password to do things. And while there are solutions for solving this problem, one thing that makes it even harder to do this properly is to account for the fact that we also sometimes have to run locally. And you might be thinking that that's only for test, but if you really look at what's happening in companies, we also have to connect to the production environment from our development machines every now and then, maybe to run a certain script for testing something, or to run a custom script for querying a number of things together for getting a one-time report. So that's the problem space that we will be talking about today. In essence, we will be talking about how to securely create credentials, distribute credentials, store them, and then use them for authentication. And normally when I'm talking to a live audience, this is where I ask the question, now, do you believe that you have this problem under control in your organization or in your team? And often quite a few people are confident that they have this under control. But then there is this second question. Have you fixed it in a way that's not a huge pain in the ass for your engineers? And then people are less confident to say yes, because there are ways we are solving this problem space in organizations, but it's a little bit at the expense of the ease of development. And let's see if we can make a difference there. In many companies nowadays, you see like three things. The first one is that they try to forbid things that are not correct or that they find insecure, and just, outlaw them within the company. And that feels really good because you feel much more secure as a CISO or as a manager. And this mostly applies to things like symmetric keys or pre-shared keys, shared access signatures they're called in Azure, or the use of system local accounts. For example, username and passwords that are created within a SQL server instead on a domain controller or Azure Active Directory. And while this not only feels good, it actually is good. But the problem here that, sometimes reality just butts in. While it is good to try and avoid not using local accounts, but if you have to connect to a system that only supports local accounts, you are in a pickle. That's not a problem that we're going to be solving today, but I really hope that we can all agree that if we build a system, please support centralized authorities like AAD or OAuth or SAML or something similar. The second thing that I see a lot is that there is a central management organization for identity. For example, a team that owns the Azure Active Directory, and you can request identities from them, but they start imposing restrictions, and often from a security point of view. For example, that means that you cannot create identities yourself anymore. You have to request an identity, and maybe that request is reviewed, or somebody has to take responsibility for the identity that's being created before the request is fulfilled. And once it is fulfilled, this is almost ironical, because then often you get the credentials via email, which is very insecure, or some internal other system. And the thing is, this central authority for providing these credentials starts imposing all kinds of things that you have to do, like changing the password every 6 months, or the account automatically gets disabled. Those passwords have to have a certain length. They have to have certain characters. If you use certificates, they have to expire after 3 months, or all kinds of things that are just annoying as an engineer because you just want to use that identity. You don't want to concern yourself with all kinds of operational responsibilities around it. Yet, from a security point of view, this is enforced for good reasons. Now, to get around this, what I see a lot is that teams reuse accounts. Instead of requesting 6 different identities for my 6 different application components with very narrow authorizations, I just request one account, reuse it everywhere, and just stack all the authorizations on that one account. That doesn't adhere to least privilege, and if that account is ever compromised, the impact is much higher than if I properly had it split into 6 identities. So to counter that, companies do what they do, and they introduce process and rules, and you have to prove that you comply with them. And there is a lot of compliance and governance. They keep track of what account is used where. You have to create reports. You have to prove that you're doing the right thing. The password requirements have to be reviewed. You have to keep track of who owns what account, etc., etc. And I think if you've worked in a big enterprise, you really recognize a lot of these things, and that they can be a pain in the butt when you're working as an engineer that just wants to access a system. So one of the things, this is a lot of things that I see happening in organizations, and central in the solution is often a thing called a key store or a configuration store. Now, there are 3 things about configuration stores. And the first one is that they're really, really good at securely storing secrets, which is what we need to do. I'm not going to do it, but I'm pretty confident that if I get a password, put it in an HSM, and then just give it to an attacker, it is very unlikely they're going to be able to retrieve my key. We're really good at storing them securely. There are 2 problems remaining. The first one is, how do you know who can retrieve them? If I'm running an HSM, how do I manage access to that HSM? And the second thing is, what happens once secrets are retrieved from a key store? Are they still securely handled at that point? Now, to look at the middle question first, I have a little bit of a story to share with you. I learned about this story years ago from somebody called Niels. And it's about a philosopher and an old lady that are talking philosophy. Things like, the original, where the world comes from, what the point of life is. And at some point in their conversation, the old lady claims that the whole world is sitting on the back of a giant turtle. And instead of making fun of her, that philosopher just asks her, that's interesting. But if the world is on top of a big turtle, what is that turtle sitting on top of? And then the lady says, that turtle is sitting on top of another turtle. Interesting, the philosopher says. But that second turtle, what is that sitting on top of? And then the old lady says, just stop it right there. I know what you're trying to do, but it's just turtles all the way down. The question is, all the way down to where? Everything has to stand on something. And the same problem we have with secrets and key stores. If I have a key and I put it in a store, what do I get in return? A key for the store. Now, where do I store that key? In another key store? But then where do I store the key that I get for that second key store? And that is a problem that is pretty hard to solve. If you are just running virtual machines, we will see how cloud or a generic platform that you're running on top of can help you solve that problem. The second thing that is a problem around secrets or passwords in general is that they're not so secret after all. We have to deal with things like compromised servers, where secrets are exfiltrated and then identities are misused. We have to deal with former engineers that take secrets home, which is why we frequently have to rotate them, but that's a pain in the butt. We have to deal with compromised dev machines. And finally, the worst of them all, we have to deal with engineers, people that are just trying to do their work the best they can, people like me. For example, this is a mistake that I made not too long ago. I had to debug a problem that was occurring in production. And to take a look at that problem, I reproduced a call to a service on my local machine using Postman. And one of the things that I had to use was a symmetric key right here. And I reproduced the problem and I reported back to the product owner, closed the ticket. Everybody was very happy. But then 2 weeks later, on another machine, I again opened Postman. And the first thing I saw was this authorization key. What happened? I am logged into Postman. And Postman is a wonderful, helpful service. And one of the things that it does, it synchronizes all my requests and my request history and all the headers to all my devices. So apparently that secret was just uploaded to the cloud and sent to all my devices. Now, I didn't do this intentionally. This was a mistake on my end. And I'm actually one that deserves a rare meme. But these are the things that happen when engineers just try to do their work, because handling secrets correctly is just inherently hard. Here's another example. This happens when you search for removed secret on GitHub. In this case, I found over 11,000 commits. And you can make variations on that search, like secret, or and you will find much more commits as well. So even while we all know that we shouldn't check in secrets, 11,000 people, or at least in 11,000 instances, somebody accidentally did it and had to fix that. Handling secret security is hard. Here's another problem. This is taken as a screenshot from an engineer that has to work a lot with customer data. And to work with that data, he has to access it from its local machine. And one of the ways to do that is the Azure Storage Explorer. And here we see that the engineer in question also connected to a production account. And he ticked, remember my credentials. So now everybody stealing that machine has access to that storage account. This is just somebody doing his work as good as he can. Let's skip this one. So if I think about this, to me, the essence of the problem here is that we are authenticating systems using something they know, a client secret, symmetric key. And I phrase this way very deliberately because it really relates to how we authenticate as people, something we knew, a password. And we saw that for persons that's not working because, passwords, there are a lot of problems with passwords. So we moved to things like MFA. We add something we have, like our phone or my watch. or something you are, like my iris scan or my fingerprint. And what if we could do the same for systems? What if we could authenticate using something they are, their inherent identity, or something they have? And that's what a Azure Managed Identity promises to deliver you, and actually does as well. So let's assume that we have some of our application code written in C# running somewhere, for example, on an app service. Now, normally you would access a resource using a username and password, or go to the Azure Active Directory using a client secret to get an OAuth token. But what if instead you would run on something, and on that something, you could call an endpoint that only your code can access, something that's local to your code. And to that access point, you can say, hey, please give me an access token, an OAuth token for accessing resources. And then that endpoint on your behalf goes to the Azure Active Directory and authenticates using a client ID and a client secret. You don't have that client secret, the something in between has. So all of a sudden, you authenticate using something you can access, or maybe even something you are, like your inherent identity. Now, if we can abstract everything, for that middleman away into the platform, that would be great, because now we can all of a sudden write code that says, hey, I want an access token for me, get an access token, and then do our thing. Now, strictly speaking, this is something you can access, maybe like my phone or my watch, and not something you are. But it comes very, very close to inherent identity of the code that is running. And instead of spending more words on it, I thought I'd just show you. Let me see if there are any questions in between. No questions yet. All right. So let's start here in the Azure portal. I prepared a number of resources in Azure, and the first one that I wanted to show you is a SQL server, on which I created a SQL database. It's a standard SQL server created in Azure, but one of the changes that I made is that for Azure Active Directory, I decided to only support logins that use an Azure Active Directory account. So no local accounts, only accessing this server using an OAuth token. Now going back into the SQL server, of the SQL database, which is right over here, I can go to the query editor, and you can see that I am now logging in using my AAD account and not using a local account. And then I can actually go into the database and perform queries. Let's just give it a second to connect. This is why I no longer create infrastructure and demos live, but always prepare things. Okay, so while we wait for that, let's take a look at something else. Open a new Azure tab, can log in, and go to my resource group. So the second thing that I wanted to show you here is that I've created an app service, which is called Managed Identity Demo 1. So if I navigate to its details, what you can see here is that there is a tab called Identity. And what I did is I turned this switch to on. What this did, it created automatically an identity in the Azure Active Directory, which returned a client ID and a client secret for authentication. And that client ID and client secret are stored within the app service on Azure. And I can now use those to authenticate using an intermediary endpoint. Now, that endpoint is available on something like http:// and then a local IP address. But as with a lot of things in Microsoft, it's abstracted away using an SDK. So let's take a look at the code that I could write to now access that database using that inherent identity. So the first thing that I'm going to do is I'm going to open a connection to my SQL database, which is done right here. And if you look closely, you see that I specify the SQL server and the SQL database but I don't specify any means for authentication. No username, no password, as you often see in a SQL connection string. Instead, I instantiate a class called Managed Identity Credential. This is an SDK class by Microsoft that I can use to get an OAuth token from without providing a client secret myself. Instead, this will use the assigned identity of my app service. Now I can use that credential to get a token that I can use to access SQL databases. This is called the audience. And now I put that access token on the connection and I can execute a query. Now the funny thing is, if I run this locally, which I just pressed F5, let's see where it pops up. We will see that this code is not running. It will not start up on my local machine. Why? It is not running within that app service that has an identity. It's running locally. This code will never, ever work. Let's just ignore that. And I will just put this to the side. So hopefully in 5 minutes, I can show you that this is not working. But I have also deployed this code into Azure. Oh, there we go already. It says I cannot authenticate. But what if we go to that same code running in Azure? So I deployed it here. We will take a few seconds to spin up, and here we go. Now my code ran, connected to the database, got 2 records, and it just blows me away. Now, if you followed along very closely, you saw that I created an app service with an identity. There's now code running on top of it. It can use that identity to go to the AAD, and it's then going into the database. The one thing that I haven't shown you is how to give that identity access to the database yet. So let's take a very quick look at how that's looking now that my connection to the database has established. Here, I'm logged in using my personal account, Henry at Azure Specialist. But one of the things that I can do here is say, create user, and then mi demo1 from external provider. This is the name of the app service that I created and for which I turned identity on. This is now the name of an identity in my Azure Active Directory. And I can create a SQL user out of that AID identity. If I try to run this, I will get an error saying that it already exists. And that's correct, because my first demo is already running. So let's recap what you've seen here. So this is a diagram that I borrowed from Microsoft. The link is at the bottom. And this is for virtual machines, but it works precisely the same way for app services. So step 1, we enabled managed identity for our app service. What the service then did behind the scenes is it's created a new managed identity service principal in the Azure Active Directory, an identity. That returns a client ID and a client secret, and that is stored in the Azure Instance Metadata Service, the intermediate endpoint that we talked about before. Then fourthly, I granted that identity access to my SQL DB. And finally, step 5, I request a token from that local endpoint, which on my behalf goes to the Azure Active Directory and returns a token that I can use to access that SQL server. So this is what's happening behind those 4 lines of code. Now, like many things, this is not perfect. But what you saw here is that switching identity on created that service principal in Azure Active Directory, and that we were able to use it. What we didn't see yet, and it's also not in the pictures by Microsoft, is that every 45 days, that identity endpoint goes into the Azure Active Directory and rotates the client secret. So even if it is exfiltrated in some way, which is not possible, it gets rotated. And if it's not for security, that's probably important for compliance, because many companies just mandate a regular rotation of secrets. So you're covered there as well. Now, this is not perfect. There are 3 challenges with managed identities. And the first one is that the identity is removed whenever the resource is removed. They are very, very closely tied together. And that's a problem if you want to remove the resource because you, I don't know, want to shut down your infrastructure every day at 5 and just spin it up at 6 to save money. Or when you just need to remove a function plan because it's in some kind of stuck mode and you just want to recreate it. Another problem is that the identity can't be shared. Well, it might sound a little bit weird, but just imagine that you have an application component that has a web server at the front, that's an API, and a backend worker that's attached to a API queue. If those two things are a logical whole, one application component, you might want to assign the same identity to both the function app and the web app. That's not possible with system identity because you have two switches that you turn on and thus two identities. And the third problem, and that's very practical, is that if you want to create infrastructure using infrastructure as code, especially using Bicep or ARM templates, the use of system managed identities can sometimes lead to circular dependencies. So we can circumvent this by switching to another type of managed identity in Azure, which is called a user-assigned managed identity. By the way, fun side note, I bought this picture for my very first presentation ever, and I'm Dutch. You might know Dutch are very cheap, so I reuse this every time since, just to make the return on investment increase every time I give a presentation. Now, talking about managed identities that are user-assigned, the difference is that the identity is not a switch on the resource. And so going back to my app service, identity, turn it on. Instead, a user-assigned managed identity is a completely separate resource. So I can just go to my resource group right here and say, hey, I want to create a new identity. So I'm not doing this in AID because I'm not just creating the identity. I'm also creating the possibility to assign it to an Azure resource. I'm going to say user assigned, then, and I can now create a user assigned managed identity. They're fairly simple to create. You just give them a region and a name, and then they're created. Now in this case, I already pre-created one, and it's called mi-demo2. Now what I did with this identity is I also created a new app service, which is called app service 2. And for this app service, I didn't enable the system assigned identity, but I went to user assigned identity and added it right here. And fun fact, you can have more than one identity assigned as a user assigned identity. The second thing I did was I created a service bus namespace. And on that service bus namespace, I want to send messages to a queue in that namespace from the code that is running on my app service. And to make that possible, first I need to have access. And in this case, access is provided using Azure RBAC. So I can go to access control and then to role assignments. And here you can see that for this user assigned managed identity, right here, with this name, mi-demo2, I assigned the role Azure Service Bus Data Center. So now code running on any resource that has this user assigned managed identity, I can send messages to the service bus queue. And to prove that to you, I've created another code example. I'm going to connect to service bus namespace, mi-demos.servicebus.windows.net. And now instead of a regular managed identity credential, I'm going to specify the ID of the user assigned identity that I want to use. Why? Because there can be multiple, and I need to specify which one to use. Using that credential, I can instantiate a service bus client, connect to a certain queue, and send a message. If you're wondering where this ID comes from, I just go back to the portal, open my user assigned managed identity, and then here at the top right, if we wait for it a little bit more. Come on, Azure, make those hamsters run. Okay. Okay, that's a bit of a bummer. Let's try to refresh this. And go back to my resource group. And then in my resource group, find my user-assigned managed identity. And for its properties, find the client ID. So here at the top right. Now again, I can try to run this locally, but it will not work. It will only work when running on the lab service. So luckily, I deployed that code as well. And just to prove to you that this actually works, let's go to mi-demo2.azurewebsites.net and see that we've successfully sent a message. So that's how user-assigned managed identities work. To quickly put the two of them, system-assigned and user-assigned, side by side, system-assigned is a property of an existing resource. A user-assigned identity is a separate new resource that is linked to an existing resource. System-assigned identities share the lifecycle with the resource that they belong to. User-assigned identities have their own lifecycle, so you can keep the user-assigned identity and just get rid of the resource it is linked to. System-assigned identities have a strong one-to-one relationship with the resource. User-assigned identities have a one-to-many relationship. So if you have two Azure resources that together make one logical application component, you can have them share an identity. And while system-assigned identities can be reassigned, user-assigned identities can be reassigned, which is helpful if you're doing something like rolling deployments. Looking back on all of this, there's one problem that we haven't solved yet. You saw two ways of running code on an app service using system-assigned and user-assigned identity, but you also saw that what I've been running doesn't work locally. So let's see if we can try and fix that. So let's just open the code for my second demo. And instead of this managed identity credential, let's see if there are other credentials that we can use. So let's say I want to use what is called a Visual Studio credential. What this will do, it will use the account that I'm logged into Visual Studio with, and use that account to authenticate against the service bus to see if I can send a message. So if I now run the code again, hopefully it comes up, it connects, and it will probably say that I'm not authorized to put a message on that queue and my demo too. So let's see what happens. Now behind the scenes, this code is looking at the account that have used to sign into Visual Studio. It will get a auth token for that account, and then it will go to the service bus and try to say, hey, here's a message, put it on the queue. And to make that possible, I need what is called a send claim. And this is an exception saying, hey, unauthorized access, you don't have send claims. So let's quickly close that. Because what happened? I am an identity that is used by the code that is running. It is accessing that resource in Azure, but I didn't put the authorization in place yet. So if I now open the Azure portal again, go to my resource group, and then my service bus namespace, and its access control, role assignments, I have to create an equivalent of this assignment for myself. And I can do that because I'm the owner of this resource. And the reason that I don't have this right inherently is that Microsoft is separating management access to a resource and data access to a resource. So I will need to become an Azure Service Bus data sender as well. So that authorization needs to be assigned to Henry, which is moi. Review and assign. And let's just wait for it to be assigned. Then just give it 3 more seconds because that's always what's needed. And now I go back to Visual Studio and run this code. And hopefully in about 30 seconds, we see a message that I have now delivered a message to the queue from my local machine running code without any secrets, using the identity that I use to sign into Visual Studio. And Wow, that's a bummer. So there might be a reason why that's going to happen. So let's go to Tools and then Options and then to Accounts. Because here you can see that there are a number of accounts that I am logged into. And I might have to select the correct one to use for accessing. Yeah, for accessing that resource. So this is my personal tenant, my personal account. Let's try this again. Meanwhile, let's quickly check. Yeah, I'm a service bus sender. And there we go. This time it worked. Maybe it just needed a few seconds for the authorization to pull in, or maybe the selection of the account worked. Now, this selection of accounts is especially helpful if you have multiple accounts or you're a member of multiple tenants. Yeah, you can pick the one that you want to use to connect. Another thing that you can do is say, hey, I want to specify some options. And this particular one is the tenant ID. If I'm a member of multiple tenants, as a guest user, I might have to specify the tenant ID of the tenant that is linked to the Azure subscription that I'm connecting to. So that's a detail that you have to put in place in some cases. There's one final problem remaining. How do we write code that can run both locally and in the cloud without requiring any changes? Because this code will now not run into the cloud. Well, there is another type of credential, which is the default Azure credential. And this credential is very special in the sense that it is made out of an order of credentials that it tries. First, it tries to get a client ID and a client secret from your environment. Then it tries system managed identity, then it tries user-assigned managed identity, then it tries Azure CLI credentials. There are like 9 of them. And you can find the order on the documentation by Microsoft. So this is a great way for writing code that works both on your local machine and in the cloud. And if you don't want to, for example, use Azure CLI credential, you can just disable it. Or if you want to specify a Visual Studio tenant ID, you can do that. Let's not do that. Let's go it up to string. You can specify options for every individual credential this way. And the final thing that I quickly wanted to show is because we don't use secrets anymore this way. But what if you're in a situation where you still need to use secrets, but you do want to switch to this style of getting access to resources? There is another thing which is called client secret credential. You can use this to specify client ID and client secret if you're transitioning to this new type of authentication. With just 2 minutes on the clock, that's all I wanted to show you. Except for one thing. This way of authentication is a great replacer for accessing any type of resource in Azure. It will work for almost all types of compute. It works for VMs. It works for app service. I think it works for Azure Batch. It works more and more types of compute support authenticating using a system assigned identity or a user assigned identity. And more resources in Azure support being authenticated too using an AID credential, SQLDB, storage accounts, Cosmos DB. You can build a system almost without any secrets. But if you still have to work with secrets, for example, when accessing a third-party API, just use Azure Key Vault. But remember, turtles all the way down. But let's use it like this. Have an app service, request a token from your managed identity endpoint, and have that authenticate to AID. So you get an OAuth token without using any secrets. Then you can access the Azure Key Vault to get a shared key. And then you can use that shared key to access another resource. A little bit of indirection. However, in this app service configuration or when running locally, you don't need to store any secrets. If you don't need to store them, you cannot accidentally keep them on your system. You cannot accidentally check them into source control. So I think this is what to do when all else fails. All right, this is the recap for those who want to quickly reread what we have been talking about, my name is Henry Veen. I do hope you enjoyed this session. And if there are any questions, I'm really happy to take them. But out of respect of your time, we're going to stop right here. Thank you. And please do try this at home. All right, I don't see any questions coming in. So in that case, thank you for your attention and have a wonderful remainder of this wonderful event. Thank you.